Welcome back to Think Thrice Problem Solving. Today we'll be solving a fun little geometry problem. So in this geometry problem, I have a square and an equilateral triangle that share a bottom edge, and our goal is to find the distance between the centers of circles that are inscribed in each of these two shapes, or essentially just the center of these shapes. So the first thing we're going to do is we notice that this length here, going down from the center of my square to the bottom, is going to be 1/2 of the total side length of that square. Similarly, the distance between the edge and the center of that triangle is also 1/2. So what we're going to do is we're going to look at this triangle, because that's really the tricky part of this problem. We're going to build this triangle right here. And we're going to note that this total angle here in a triangle is 60 degrees, or pi over 3. So if we were to look at the smaller angle right here, this is going to be a 30-degree angle. So let's go ahead and isolate that triangle and take a look at it. So if that's 30 degrees, so we have a side length of the long side, which is 1/2. And typically, we would have the long half divided by the hypotenuse is going to be √3 over 2. So 1/2 over h is going to be √3 over 2. So that tells us that h is going to be equal to, if we put those guys out, 1 over √3. So then I can quickly solve for this last guy. So sine of 30 is 1/2. So 1 over √3 sine of 30 is going to be 1 over 2 square root of 3. So this length right here is going to be 1 divided by 2 square root of 3. So 1/2 square root of 3. Okay. So now we're most of the way kind of through a lot of the heavy lifting. So let's look at another triangle here. So let's bring this over, and let's look at this right triangle here. So I have a right triangle, so if I look at this side right here of my right triangle, this is going to be 1/2 minus 1 over 2 √3, which I just calculated. Okay? And then this long side is just going to be 1/2 plus 1/2, which is going to be 1. So if I use the Pythagorean theorem, I can see that x squared is going to be the square root of 1 plus 1/2 minus 1 over 2 √3 squared. All right, so we could just, x squared is going to be equal to that whole thing on the right squared. Okay, so we could go ahead and simplify this just a little bit. So x is going to be the square root of 1 plus 1/2, and I'm going to go ahead and multiply some of this out. So we're going to go ahead and get 1/4 minus 2 times 1/4, 1 over 4 √3. So we're going to get 1 over 2 √3. And then we're going to get plus 1 over 2 √3 squared, which is going to be 1 over 12. All right, so I can go ahead and add some of these together. So we're going to get x is going to be the square root of 12 plus 3 plus 1 over 12 minus 1 over 2 √3, which is going to give me the square root of 16 over 12 minus 1 over 2 √3. And that is actually going to be my answer. So there might be a little bit more simplifying you can do, but it's not going to get much prettier than that. And that's going to be our solution. So I hope you enjoyed working through that problem with me. If you did, please like and subscribe. If you have your own problem that you'd like me to do, please submit it. Otherwise, as you're working through problems, think once, think twice, and if you really get stuck, think thrice.